Okay, the next what we see is the velocity time graph. So next is velocity time graph. Okay. So velocity time graph. Right, perfect. Now, so again the same thing. We have this particular y-axis and the respective, this one is the x-axis. It will be seen that this will be the time and this will be the velocity. So velocity time graph, this will be meter per second, or better write it as meter minus 1, second minus 1, and this will be in second. So the velocity time graph will be a graph which is drawn between the velocity of any particular body with respect to time. So as we did for the displacement time graph, we'll start again with the same thing. If the body is such that it is giving a graph which is exactly on the x-axis, that means my time and velocity are such that time is 0, this is 0, 1 फिर भी 0, 2 फिर भी 0 and 3 फिर भी 0. If this is a condition over here, then you can see you will be getting the graph like this, because it's 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5, 6. Okay. So you can see that if it is a straight line like this, what does it indicate? You can see that my velocity is 0 in each and every case, hence the body is at rest. So if the line is on the x-axis, then the body is at rest. Now we'll change it a bit. We are going to take this point at point 3 इस तरह से. So we have over here the velocity is not 0, but it is over here 3, 3, 3 and 3. Now what happens? Is the body at rest? No. The body is not at rest, but the body is traveling with a uniform velocity of 3 meters per second continuously. Okay? The body is traveling continuously at a uniform speed, uniform velocity. Over here velocity, the distance is also, direction is also the same. So it indicates that the body is traveling with uniform velocity. So it concludes that if the graph is a straight line parallel to the x-axis, then it is traveling at a uniform velocity. You can see that even this is uniform velocity because 0 पूरा 0 ही है, इसलिए वो भी uniform ही हुआ. So at rest is also uniform velocity, where velocity is equal to 0. So here, if the body is traveling in a straight line, if a body is traveling with uniform speed or uniform velocity, then you will be having a graph which will be parallel to the x-axis. So that is the first part. Next we see is the condition in which the body is going to, or the graph is going to be moving like this. Okay, that means 1 pe velocity over here is 0, but over here is 1, this is 2 and this is 3. That means velocity over here, if 1 के लिए 1 है इधर, 2 के लिए 2 है इधर, 3 के लिए 3 है इधर. So if it is like this, अगर यहाँ पे 3, we just change this thing over here, make it 3 over here, 2 here. So just to represent it in the right form. So if this is a condition over here that the body is, the graph is an inclined line, the graph is an inclined line to the x-axis, a straight line inclined to the x-axis, then this is going to tell you that it is a non-uniform velocity. But you can see one important thing over here is that acceleration over here, we know acceleration is v upon t. So over here 1 upon 1 is 1, 2 upon 2 is also 1 and 3 upon 3 is also 1. So acceleration over here will be 1, 1, not 0, for this will not take, but it is 1, 1 and 1. So that means that if it is if the graph is an inclined line like this, it is going to represent a uniformly accelerated motion. a uniformly accelerated motion is going to be depleted by this particular kind of a graph. Now let's see what are the different things what we can understand or we can find out from a velocity time graph. Now the velocity time graph, you can see over here, the first thing is, suppose we take this particular graph, the red one. Let's erase the next, we'll draw it again later on. If I take this particular graph over here, I know this is velocity and this is the time, and I also know a formula that velocity into time is going to give me something. What is that? Displacement. So displacement is nothing but velocity into time. Distance is speed into time. If you can recollect it that way, distance is speed into time. So displacement is equals to velocity into time. So, and if I draw a line like this, I can see this area, what is shown over here, is nothing but velocity into time. That is nothing but 3 into 4. Means the area is 12. This is in meter per second into second. Second cancels. So is equals to 12 meters. So you can see over here that this area what you get over here is the displacement. That means that the area of the graph enclosed with the x-axis gives you the displacement of that body. The body का displacement जो है, that is going to be available to us by the calculation of the area in which this is enclosed. You can easily see one more thing. Like for example, let's take another example wherein we are going to take the line to be something like this. So the enclosed area is this much. Okay. So what is the area over here? It is nothing but area is half into base into height. The base is 4 and the height is 3. So this is going to be 2. This is 6 meters. So you can see that if this graph is an inclined line over here, then the inclined line का जो area जो है, that area what is going to be here will be giving you the displacement of that particular body. So area of the graph enclosed, area of the enclosure of the graph with the x-axis is giving you the displacement of the body. So velocity time graph से हम लोग को displacement भी मिल सकता है, right? Another thing is, we know one more formula that was about acceleration. So we know that acceleration is equals to nothing but change in velocity upon time. Change in velocity is nothing but y2 minus y1 upon x2 minus x1 in this case. You can remember जो displacement में था वही चीज. If I take these 2 points, if I take this point and this point, what is going to happen? This is going to be 4, 3 and this is 0, 0. So what happens? Here it will be y2 minus y1. So it is, this is x2, y2. This is x1, y1. So it is y2 minus y1 is 3 minus 0 upon 4 minus 0 is equals to 3 upon 4. What is this? This is nothing but acceleration. So that means, what is the formula for this? The slope of the line. So the slope of the line in case of a velocity time graph gives you the acceleration of the body. So the slope of an inclined line over here gives you the acceleration of the body. So similarly, if there is a motion which is giving you a curve like this, तो curve का मतलब क्या होगा? That the velocity is keeping on changing in a different form, so it is non-uniform. And the slope, what we find out by taking the tangent, then that will give us the average acceleration, the instantaneous acceleration of that body at that particular point. So that gives you the conclusion that the velocity time graph can not only tell me that what is the type of motion which is going on by the inclined line and the straight line and parallel line and all, but the area of the graph can give me the displacement and the slope of the graph can give me the acceleration. So all the things, displacement, velocity to d raha hai, and the acceleration, all three can be found out using the velocity time graph. Now we see the positive negative part also. So let's consider that we are going to have a new kind of graph. So let's see the graph first and then we will understand what is it about. Let's consider that there is a graph over here which such that this is 0, this is 10, this is minus 10, and this is my central line, origin ka x-axis, this is the time axis which is here, and this is the velocity over here. Suppose the body is traveling this way, that it comes here at this particular point, goes here at this particular point, then comes here, then this goes here straight over here, then it comes over here, and then again it goes here and then comes down here. So suppose that this is point over here is a point 10 seconds, this is 15 seconds, this point over here is 20 seconds, this point over here is 30 seconds, this is 35 seconds, this is 40 seconds, and this is 45 seconds. These are the point at which the body, so body is traveling in this particular way, that the velocity time graph is drawn in this particular fashion. What do we understand by these graphs? What do we understand by this up down motion and up and the different kind of slopes? Firstly, let's understand the slopes. That means let us understand the different accelerations that are taking place over here. It is starting from O, reaching a point A. Because it is a positive slope, so you can see the slope will be such that it will be 10 minus 0 upon 10 minus 0, ऐसा करके आगे 10 upon 10 आएगा. So it will be 1 meter per second. Positive. You can check it out. This is nothing but 10 comma 10 and this is 0 comma 0. So my slope OA, slope will be equal to 10 minus 0 upon 10 minus 0 is equals to 1 meter per second square. That's the acceleration over here. So positive acceleration. If I am taking at this point over here is nothing but 15 comma 0. So if I take out this point as AB, this is AB ka slope will be equal to, this is y2 minus y1, so it will be 0 minus 10 upon 15 minus 10. It will be minus 10 upon 5 is minus 2 meter per second square. So this negative over here. What does this negative sign indicate? It indicates retardation. A body which was traveling at a high speed, वो जा रहा था, उसका speed increase हो रहा था, and increase होते होते यहाँ तक पहुँचा. वहाँ पहुँचने के बाद में यानी 10 meter per second पहुँचने की speed पहुँचने के बाद में, the brakes were applied, and in 5 seconds it came to rest. Now what happens? This is going to go downward. That means the body is now going in the opposite direction. The velocity is negative means it is going to go in the opposite direction. That means अगर मैंने बॉडी का अगर मोशन ट्रैवल करने का देखा तो क्या होगा? ये जीरो से चालू किया उसने, ये जीरो से इधर 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 गया वो, ये पॉइंट ए आ गया, ये पॉइंट ए आया, ये पॉइंट at this particular point, at this point he was increasing its speed, then the brakes were applied and by the point it reached the point B, it came to rest. Then what happened? It took a U-turn. It took a U-turn and it reached point C. It reached point C over here. This is point C. And then it traveled. So here the speed is keeping on increasing. Okay, retardation. Now it is negative over here. So that's what is acceleration. And at a particular point at minus 10 over here, that means when the speed became 10 meter per second in the negative direction, in the opposite direction, that is when it became 10 meter per second, at that time, it maintained a continuous speed and traveled till D point over here like this. After reaching that point, the brakes were applied and reached the point E over here. So it reached the point E over here where it stopped when the brakes were applied. Understood? So again over here, this is retardation. So this is acceleration. This is retardation, this is acceleration, this is uniform, so no access, zero, acceleration is 0 over here, and over here again retardation. On reaching this point over here, again there is a U-turn. They are taking a U-turn and coming to this point over here, F. So it is coming to the point F, and then it is retarding and coming to, so this is point F and then coming to point G. That is, this is point G. So again, this is acceleration and this is retardation. So the graph में acceleration कौन सा रहेगा? Positive. जो ऊपर की तरफ जा रहा है, that will be positive acceleration. जो towards the origin आ रहा है, towards the x-axis आ रहा है, that is retardation. Away from the x-axis, acceleration. Towards the x-axis, retardation. Away from the x-axis, acceleration. Towards retardation. Okay, that was about the acceleration time. Now we see the displacement and the distance. What is the distance traveled over here? The distance traveled over here is the area of this part. Now let's put the area over here itself. It is half into, now this is 15 into height is 10. So this gives you 15 5 is 75. So it is 75 meters over here. That means from origin to A over here is 75 meters. Sorry, 8, not A, it is B, up to this point is 75 meters. This complete thing is 75 meters. Let's take this part. We know that this is nothing but trapezium, so it is half into sum of parallel sides. Now this point is 30 minus 20 is 10, and this is 15 and 35. So 15 is 20. So it is 20 plus 10 into, what is the height? Height over is 10, so it is 10 over here. So this is going to be 5, so 30 into 5 is 150 meters. That means it is traveling from here to here, that is 150 meters. Got it? This is the displacement of this part. Let's take the displacement of this part. It is nothing but half into 10 into 10, that is nothing but 50 meters. So this point over here, from here to here, this point is 50 meters. So 75 over here, 50 over here, and 150 over here. So what do we see? The displacement will be the sum of the positive direction, that means towards the origin wala, away from the origin wala, and this will be towards the origin wala. So therefore displacement will be equal to 75 plus 50, that is this plus this, minus 150, which is this, which is equal to minus 25 meters. That means your start point was 25 meters, or say your end point is 25 meters. This is 25 meters. From here to here is 25 meters. So this is 25 meters beyond the start point. When you went here, you came back here, went here, and then came to this point, such that the distance between the start point and the end point is 25 meters in the negative direction from the original direction in which the body was moving. So this minus 25 indicates that उसने overshoot करके इधर आया और उसके बाद इधर वापस आया. So that's why it is minus 25 meters over here. Now what is the distance traveled? Now distance, it does not require any direction. तो ये भी distance है, ये भी distance है, ये भी distance है. So it is nothing but 75 plus 50 plus 150. That is nothing but 275 meters is the distance. So the velocity time graph में x-axis के ऊपर वाला will be the positive displacement, x-axis के नीचे वाला will be negative displacement. The difference between the positive and the negative will give you the net displacement. Sometimes the net displacement can be positive also, it could be negative also, or it could be zero also. If the start point and end point are the same, then it could be zero. Like for example, if I start from this body, आगे यहाँ पे जाएगा और दीवार को टच होके वापस आएगा, उसके बाद मैं उसको पकड़ूंगा नहीं और वो उधर दूसरी दीवार पे जाएगा और वापस आएगा, तो वो जाके वापस आया, तो it will come to a point which is the start point itself. Hence the net displacement will be zero. So that's why we see over here that how the velocity time graph not only tells you the acceleration by the slope, the retardation also, and it also tells you the distance and the displacement it is going to travel. Hence we see over here the conclusion of this particular part, that is, for motion with uniform velocity, the velocity time graph is a straight line parallel to the time axis. If the velocity time graph is a straight line inclined to the time axis, the motion is uniform acceleration. And if the velocity time graph is a curve, the motion is non-uniform acceleration. Okay, so straight line is going to be parallel to the straight line will be a uniform velocity, other one will be inclined line will be a uniform acceleration, and finally non-uniform if it is a curve. The slope of the straight line or the tangent to the curve at an instant gives the acceleration at that instance. We saw that. The positive slope means velocity increasing with time, so in the acceleration motion. The negative slope means decreasing with time, retarded motion. And zero slope implies motion with constant velocity. So if the motion with constant velocity, it is going to be a zero slope. Now, knowing the acceleration slope at different instances from the velocity time graph, we can draw the acceleration time graph also. I can find out the different velocities. I can see the acceleration over here, acceleration over here, and make a table of that particular thing. And accordingly, I can make an acceleration time graph from the velocity time graph. Secondly, area enclosed between the velocity time graph sketch and the time axis of the certain time of a period interval gives the displacement in that interval of time. The area above the time axis gives the positive displacement, while the area below the time gives the negative displacement. Accordingly, knowing the distance or displacement in different time intervals from the velocity time graph, we can draw the displacement time graph. So hence we see from the velocity time graph, we can make the distance time graph as well as acceleration time graph. Okay.